In this video, I'm going to talk about horizontal asymptote and the slant asymptote. Okay, let's record the end behavior of a polynomial function. And we know that the end behavior of the polynomial function depends on the leading term of that polynomial, right? If it's a even with the degree, and then it would be similar to the quadratic function, look like this way. And then if it's odd, it will be similar to the cubic function. So this is similar to the rational function. So rational function and behavior also depends on the leading term. So the leading term is the ratio of the leading term of the denominator polynomial and the numerator polynomial. So for example, let's take a look. 6x cubed minus 2x over 2x cubed plus 4x squared. So in this rational function, we have a leading term. On the top, the numerator is 6x cubed over 2x cubed in the bottom. So simplify is equal to 3. So let's take a look. What does the graph look like if this is for this rational function? So we have y equals to 6x to the cube minus 2x divided by 2x cubed plus 4x. Oh, did I do it right? Yes. So let's zoom out. And we found that the leading term is y equals to 3. So look, I'm going to use a -9 since the asymptote doesn't exist. So look, the graph is approaching to 3. When we're talking about the end behavior, meaning that as x approaching to infinity, such as approaching to the right, where does the y go? Y goes approaching, or y goes towards 3. And then as x goes to the left, which is the negative infinity, y goes to 3. Really trying to approach to 3. So end behavior says that as x approaching to positive infinity, y goes to 3. As x goes to negative infinity, y goes to -3. So that gives us a horizontal asymptote, y equals to 3. All right, so second example, if we have 6x, let's say this is 3 minus 2x over 2x, 2x squared plus 4. So that means, no, let's do 3 and 2 on the top. So that means the leading term, it will be 6x squared over 2x cubed. If we simplify, we'll get 3 over x. So this is going to be similar to 1 over x. Now, let's recall, what does 1 over x look like? The reciprocal function. The reciprocal function look like this way. So the end behavior is approaching to 0. So let's check on our decimals. So if I change these to power 2, and then this has become +4. Look at this. So that means the asymptote is what? If it's similar to 1 over x, the asymptote would be the x-axis. Look, the graph is really approaching to the green line, which is y equals to 0, the x-axis. So that means if the leading term is similar to 1 over x, the reciprocal function, as x approaching to the positive infinity, y approaching to the x-axis, as x approaching to the negative infinity, y also approaching to 0, the x-axis. Okay, next one. What if we have this case? So that means we have leading term 6x cubed over 2x squared. Simplify it, we have 3x. Now, let's take a look. What does the leading term look like if it's in that case? So we have 3 on the top and 2 in the bottom. So what does the graph look like as x approaching to 0? Well, the graph goes up like a straight line, and then if x approaching to negative infinity, y also goes down along this line. What's this line? This line is quite look like 3x, right? It looks like similar to 3x, which is the leading term ratio. If the graph look like this way, that is a non-flat line. We call this is slant asymptote. So that means as x approaching to infinity, y approaching to 3x. As x approaching to negative infinity, y also approaching to 3x. This is a slant asymptote, y equal to 3x. And previous one is we found a horizontal asymptote, y equals to 0. Yeah, here is the asymptote that we found. Okay, I'm going to mark this. If the end behavior of a rational function is a non-flat line, we call that a slant asymptote. I use the word SA as an acronym. Okay, so let's do some exercise to identify any horizontal asymptote or slant asymptote. If I got y equals to 4x cubed minus 10x plus 3 over 2x cubed minus 1. We need to find the leading term of the rational function by finding the leading term of the numerator and the denominator, which is 4x cubed over 2x cubed. That gives us 2. So that means we're expecting a horizontal asymptote y equals to 2. Check this on decimals. Next one, y equals to x squared minus 4x plus 1 over x plus 2. The leading term of this function is x squared over x, which is x. Well, this doesn't look like a number, so we're expecting a slant asymptote. So how do we find the slant asymptote? We need to use the long division to find that. We need to use the numerator divided by the denominator. So let's do some review very quick how to do the long division. So we have an x, here is x squared, so that means we're missing an x. We use x times x plus 2, so that gives us x squared plus 2x. And subtract them. We have x squared minus x squared gives us 0. Negative 4x minus positive 2x, which is negative 6x. And now the coefficient is negative 6. So that means I need to subtract a negative 6. So I have, and drop the plus 1. So I have a negative 6x minus 12. So I have a 0. Equals to 1 minus negative 12 is 13. So that means the whole function is x minus 6 plus the remainder 13 after the long division. So the Slant asymptote should be this guy, x minus 6. Let's check this on the decimals. So we have the function s squared minus 4x plus 1. Denominator is x plus 2. And we found our Slant asymptote is x minus 6. So look, the function is really going along this line. Again, this should be a dashed line because asymptote doesn't exist. So the reason I use a solid line because I want you to see it clearly. So this is the Slant asymptote of this graph. Remember that we need to use our long division to help us to find the Slant asymptote. So Slant asymptote is y equals to x minus 6 in here. Okay, next one. The last exercise is x squared plus 4x over x cubed minus 8. The leading term is x squared over x cubed, which is 1 over x. So that means we're expecting the asymptote is similar to 1 over x. 1 over x look like this one. So that means we have a horizontal asymptote y equals to 0. The x-axis, it will be our asymptote. Again, we can check these on the decimals. So we have this one. So the graph is x cubed minus 8. On the top is x squared plus 4x. Yeah, look. The asymptote. I know it's very hard to see. Let me change back to solid 9 so you can see it more clearly. See? The graph is really approaching to the x-axis. Okay, that's it for the horizontal and the slant asymptote. I'll see you in the next video.